Hello everyone and welcome to Tutorials. Today we're gonna solve remove duplicates from sorted array 2. This is actually very similar to the remove duplicates from sorted array problem we have previously solved with slight differences. If you haven't seen the video on remove duplicates from sorted array, I highly recommend you do so from the link in the description because the intricacies of the problems and the approaches are very similar. So, given an integer array nums sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Furthermore, the question wants us to place the result in the first part of the array nums. So, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It doesn't matter what you leave beyond the first k elements. So, we need to return k after placing the final result in the first k slots of nums. And we also need to do this by modifying the input array in place with O1 extra memory. In this problem, we actually allow two of the same number to sit next to each other as presented by the question prompt. That is, if there are at least two instances of the same number within the array, we will keep only two of them and eliminate the rest. In addition, since the array is already sorted, the final array without the duplicates needs to be in sorted order as well. Now, let's take a look at some examples to further understand the question. In the first example, we're given an array with 3 1s, 2 2s, and 1 3. We need to eliminate this extra 1 and place the rest of the elements towards the left. In the end, we need to return 5 because the relevant portion of the array after eliminating the extra 1 has a length of 5. We didn't eliminate any of the 2s because unlike the last problem, we allow at most 2 instances of the same number. This part of the array is denoted with an underscore because what value sits in there is not relevant at all because the relevant portion of the array is of length 5, which should be placed in the first 5 spots, and we don't care about the rest. So let's talk about how we can efficiently solve this problem. We're actually gonna attain a very similar approach compared to the solution of the first question. We will have 2 pointers again, and the right pointer is gonna visit each element one by one, and the left pointer is gonna place the visit value at the beginning of the array if there are already 2 instances of it in the portion that is already processed by the left pointer. In order to find out whether we already have 2 instances of the same number or not, we're going to compare the current visited number to the second to last number that is placed. If they're the same, we need to eliminate the visited number as there are 2 instances of it. We will perform this elimination by just advancing our right pointer and not incrementing our left pointer. Also note that in the original array, the same numbers are going to be found back to back to back if there are multiple instances of them. Just looking at the second to the last place value is enough to determine whether we have 2 instances of the same number because by visiting each element from left to right and placing them accordingly, we ensure that the sorted property is preserved in the place numbers. So if the current visited element is the same as second to last placed element, we can be sure that the last place element is the same with our visited element. In the end, we need to return the left pointer as it will contain the length of the relevant portion of the array, just like in the first problem. Now let's see how this algorithm operates on an example to better understand the solution. Let's say we have the following nums array, and the values to the top are the indices of the individual elements. L here denotes our left pointer and R denotes our right pointer. We're going to initialize our left and right pointers to the second index because the first 2 indices are guaranteed to be valid as we allow 2 duplicate numbers to sit next to each other. Now our right pointer points to this one, and now our second to last place element is 0. We calculated the index of the second to last element by decrementing 2 from our left pointer, which is intuitive because our left pointer is going to point at one place to the right of the relevant portion of our array. Now we see that this one is not equal to this 0, so we need to place our visit element, which is 1, to the place that is pointed by our left pointer, which is the second index. So 1 is going to stay here. Now we increment our left and right pointers and move on with our algorithm. Now our right pointer points at this one, and our second to last visited element is now this 0. Since they're not the same, we again need to place our visited value to the place pointed by our left pointer, which is this place. Now we advance our left and right pointers again, and now our visited element is this one, and our second to last place element is this one. Now we can be sure that there are 2 consecutive ones placed next to each other in the relevant portion of the array, whose bounds are marked by our left pointer. This is actually the case because in the previous 2 steps of the algorithm, we have placed these 2 ones in these 2 indices of the array. And if we place this one in the relevant portion of the array, we're going to violate the duplicate rule set out by the problem and return a wrong result. So now our left pointer needs to stay at the 4th index, and we need to advance our right pointer to the 5th index. And now our visited value is this one, and our second to last place element is this one. And again, we see that they're the same, and we can be sure that there are two consecutive ones placed next to each other. We shouldn't do anything and advance our right pointer to the 6th index. And now our current visited value is this 2, and our second to last place element is this one. We see that now they're not the same, so we need to store this 2 at the place pointed by our left pointer, which is here. Now we advance our left and right pointers. Our current visited element is 3, and our second to last place element is this one. Since 1 is not equal to 3, we need to place the 3 at the 5th index, which is the index pointed by our left pointer. So now we're going to put 3 in here. And we advance our left and right pointers again. And now our current visited element is this 3, and our second to last place element is this 2. Just like before, they're not the same, so we're going to store the 3 in the 6th index. Now we increment our left and right pointers. And now we see that our right pointer is out of bounds, so we can stop our algorithm. Now we need to return the left pointer, which is going to store the length of the relevant portion of the array. And this is actually the case in this example, because if you have a look at the first 7 elements, compared to the original array, we only allow at most 2 instances of the same number. And we can ignore these 2 3s, because they can be considered out of bounds, as our new length is 7. Now let's talk about the time and space complexities. The time complexity is O of n, where n is the length of the array, and the space complexity is O of 1. This is because we visit each element once, and placement is a constant time operation. On the other hand, the space use is constant, as we're only using 2 extra pointers. Now let's code the solution. So the first thing I'm going to do is check the length of the array. And if the array's length is less than or equal to 2, we have a valid array, so we can instantly return the length of the array. This is because we allow the unique element to appear at most twice, and if the length of our array is less than or equal to 2, we can be sure that the unique element appears at most twice, because there's no room for a third value. Now that we have handled the most basic case, we can initialize our left pointer, which I'm going to call the place index, because we're going to use it for placement. And our right index is initialized to the 2nd index and go to the end of the array. We'll then access the visited num using our right pointer. And as I've mentioned before, if our visited num is not equal to the second to last place element, we don't have a duplicate, so we can place it to the place index. And in this case, we need to increment our place index. And in the else case, where our visited num is equal to our second to last place index, we have a duplicate that appears twice. So we only need to increment our right pointer, which is handled by this for loop. So after removing the duplicates from the beginning of the array, we need to now return the place index, which denotes the length of the relevant portion of the array, as I've mentioned. And that's it. Now we can hit submit. As you can see, the solution is correct and pretty efficient. If you found this video helpful, please like and subscribe. It helps the channel a lot, and I'll see you in the next one.